Okay, so we heard before in Yoav's talk that the performant web, you might say, is built on 3 pillars. And one of them is the ability to actually monitor your performance. And this is what I'm going to be talking about. What this talk is going to focus on is about the awesome web performance APIs. It's actually a collection of multiple APIs that you can use to monitor the performance of your website, and we will see examples of how this can be extremely useful. So by the way, this is a fairly large topic. In fact, I gave a 3-hour workshop on this very topic in O'Reilly Fluent, and I'm going to be giving another workshop on this topic, a 4-hour workshop on this topic, which means I have to come up with another hour of content in the You Got to Love Front-End Code Camp. So if this seems interesting to any one of you and you want to not only hear about it like an overview, but really dive into the details and do some exercises, do some coding and hacking on the fly, I recommend that you sign up. It'll be fun, I hope. So first of all, to introduce myself, hi. My name is Dan. I work at Wix. I've been with Wix for 4.5 years, almost 5, which makes me really one of the old timers at Wix, turns out. And it's a fun company. And my job at Wix is I'm the performance tech lead, which means that it's my responsibility to focus on the technology that makes it possible for our websites to load and execute as quickly as possible. So it's over 100 million websites now. In fact, every time I do this presentation or any other presentation, the numbers just keep running up. When I can make a difference, it really starts impacting the web when you're talking about so many sites, because one of the benefits is that when I can add technology that makes stuff load faster, then all the sites on Wix actually load faster, and they don't actually need to go and change anything. It can be a 7-year-old site and it'll still load faster. But conversely, if the developers do anything that makes sites load more slowly, then they've adversely impacted 100 million websites, and that's really, really bad. So in order to guarantee that something like this does not happen, we have to be able to actually monitor the performance of our websites, so that if we do degrade in terms of performance, we can find out and roll back, revert whatever bad change that we've made. So you don't really need to be super smart these days to know that web performance is really, really important. But nonetheless, I'll give you a short explanation of why that is. So this is a slide from last year from a company called Pingdom that really focuses on web performance measurements and tools. And the interesting line here is the blue line. I apologize for the really small numbers, but basically these are just percentiles. So this is 0, 10, 20, all the way to 100%. And these are just seconds. So this is 0, 1, 2, 3, 4, 5, and so forth. And the blue line shows the bounce rate, which basically means the number of users that visit your site and then leave before the site is really fully loads because it's taking too long to load. So you can build an amazing website and with lots of interesting features and useful features, but because all these useful features take time to download, then people will actually leave your site and never get to experience those great and excellent features. So for example, we can see that at around 4 seconds, you get approximately 20% bounce rate. But if you get to 6 seconds, you're already at 40%. And 7 seconds, you're at around 50%. So that means that if your website takes 7 seconds or longer to load, you're losing over half of your potential visitors. And you know where they're all going. They're going to your competitor's website. That stupid website that's lacking all these features, but because it's lacking all these features, is loading more quickly. So obviously, loading quickly is really, really important. So let's say we are trying hard to build a site that loads quickly. How do we know that it is in fact loading as quickly as we want? And even if we achieved that good performance, how do we know that we're able to retain it and that we don't regress? Well, fortunately, there's a collection of APIs built into the browsers, actually essentially all the browsers, because they are web standards that are supported by all modern browsers, that can provide us with really the internal information that the browser itself collects, various timing information that the browser has access to, and that browser can report back to our code. When we're thinking about what type of performance information the browser can report, I really like to look at performance in terms of 4 categories that are part of the rail model that has been really promoted by Google, and this is yet another good contribution that Google has made to the community in pushing this model. And because it's, Google is an American company, they really like acronyms. So here it's RAIL, which stands for Response, Animation, Idle, and Load. Response basically means the time that from, let's say, you clicked on a button, how long before something happened, the user experienced any sorts of response to their interaction. Animation talks about the smoothness of the animation. You're running a video or some sort of animation. How smooth does it look, or does it look janky and with breaks? Idle, let's skip that. And load basically just talks about how long the page takes to load. Response, by the way, you want it to be under 100 milliseconds. Animation, ideally you want 60 FPS, which means that at most you have 16.6 something milliseconds per frame. In fact, you have less because the browser also needs some time. And we'll talk about load. With load, you actually have several metrics. You have first contentful paint, and you have time to interactive. So, for example, for contentful paint, the numbers that Google are currently pushing is you want the contentful paint to be under 1 second. On mobile, they're willing to give you a break and say 1.2, but that's more or less the areas that you want to hit, the numbers that you want to hit if you want to be considered as having really good loading performance. And as you have mentioned, there are other metrics having to do with load times, like time to interactive and so forth. I won't go into all of these metrics. So let's say I want to measure all of these performance metrics. When do I want to measure them? So in fact, there are 3 different stages in which I may want to measure the various metrics. First of all, during development. So I'm writing code, I'm building a website, I'm writing JavaScript, I'm running, let's say, maybe a local server, and I'm trying to understand how, the speed, the performance of the website that I'm building. And I've got these excellent tools like the Chrome Dev Tools that I can use to do measurements. Well, it turns out that using the Web Performance APIs, I can in fact augment my experience when I'm using the Chrome Dev Tools, and hopefully I'll have a little bit of time to show you what I mean. On the other end of the spectrum, I want to get something called RUM, which is real user measurements. I want to collect actual data from the field. Now, you might be using a third party for that, or you might be building your own solution. But regardless, either way, inside you're going to be using the Web Performance APIs probably to collect performance data. So it's either your own code that does the collecting, or you're using some third party that does the collecting for you. And finally, in between the two, you will ideally want to do some sort of a pre-release testing, running what's known as synthetic tests. So for example, you can use something like Lighthouse CI to automatically run tests every time, let's say, you have a release candidate, and to prevent you from pushing out into production something that might regress your performance. Well, how is Lighthouse able to measure the performance of your site? Well, internally, it's using various calculations that are essentially built on the Web Performance APIs. So this is actually an example of some data that we collect at Wix. By the way, we currently do most of our collection ourselves. So the performance data that we collect from the endpoints, from the browsers, are actually using our own system. We are large enough that we can afford this. In fact, we are large enough so that we kind of have to do it, because if it's a third-party solution, we end up paying too much, because they usually charge based on the amount of data that you're pushing into them. So some of the data that we collect from the field, and I don't know if you do that, but this is just an example of some of the stuff you can collect. We're actually collecting the DNS times that we're getting. So we can actually monitor the quality of service that we're getting from our DNS provider. And if the DNS is not the provider that we're using in some geo, it doesn't provide good enough performance, we may decide to switch. Likewise, we're looking at the TTFB, the time to first byte of the various resources that we download. So these are metrics that we can get out of the Web Performance APIs, and we actually use when monitoring the performance that our users experience. So let the dive begin, although in this case, as I said, it's going to be a somewhat shallow dive due to time restrictions. From the user's perspective, there is zero time. The time when the whole loading experience starts is when they actually click the link that led to your site. So for example, they did some Google search, one of the links was yours, you were lucky enough that they actually clicked that link. But from the user's perspective, that's the zero time. The problem though is that your code, your HTML, everything, your JavaScript has not loaded yet. It's only when the user clicks the link, sometime after that, that the browser actually starts downloading your stuff. So, measuring, so basically what you want to do is to measure stuff that actually happened before your code actually loaded. I gave the example before that you may want to measure the DNS. Well, the DNS obviously happened before your code was even there. So how do we measure something that happened before our code was there? Fortunately, the browser records this information, and then when our code does arrive, we actually have an API that gives us access to that. So one example, probably the simplest one, is the timing API that you can, in the past, when we wanted to measure something, let's say we had some operation in our code and we wanted to measure how long it takes, we would probably use something like date now, or if we're really old school, new date. Well, that's really not an ideal way to measure timings. Just for an example, the values that you're using are the Unix epoch. They're really big numbers. They're not really so meaningful in the context of the session. So instead, we now have a much better solution in the form of performance now and performance.timeOrigin, which basically gives us a high resolution timestamp with a zero time that matches the beginning of the session. So timeOrigin really gives you the Unix epoch of the beginning of the session. I'll show a little bit more detail what I mean by that. And performance now gives you the time from the time of origin until when you made the measurement. The numbers will still be in milliseconds, but you will see that the resolution is actually higher. You see that the resolution is actually in microseconds. Actually, it's not quite microseconds, because as you have hinted, giving you direct access to the exact microsecond would enable things like fingerprinting and stuff like that. So it's a bit fuzzed, but it looks like it's like a microsecond resolution. So it really gives you a good resolution into the exact amount of time that processes in your system have taken. Okay. So the simplest API that we might use is performance now. We can simply put performance now in one point, performance now in another point, and then we can just measure the amount of time that, let's say, some computation has taken. But that, again, doesn't help us with stuff that took place, for example, before our code even was loaded, or maybe things that don't invoke code at the beginning and the end, like stages during download of resources. So for that, we have something called the performance entries. So basically what happens is that browsers store performance-related information in an internal buffer. And whenever certain types of events that get recorded occur, a new entry is created and put into that buffer, and they're put in order. So you can then afterwards go back to that buffer, extract entries, and because they're in order, it makes it easier for you to kind of figure out what happened first and what happened next. And you have an API that gives you direct access to these entries. So what type of entries do you actually have inside there? So there's actually a long list, and it's a growing list. So this list was correct more or less when I created this slide, but as you have hinted, they keep on insisting in adding more and more types of entries to that list. All of them begin with the word performance, and then you've got the name that explains what it means. So you have navigation timing, resource timing, pane timing, so forth. I'll show you some of them, not all of them. But again, you might recall some of the names from what Yoav was talking about, like the long task timing entry. So how do I actually access these entries? So in order to access these entries, on the performance object, I have a couple of methods. The easiest one, most obvious one is getEntries, which basically just returns to you the current list of entries that you have. And then you have additional two methods that give you the ability to filter on it. So you can either just request everything, essentially you're getting back an array, and then filter it yourself in your JavaScript. If you want to do it a bit more efficiently, you can let the browser do some of the work for you, and you can use functions like getEntriesByType. We saw the various types. This makes it possible for you to restrict to a certain type, or you can filter by the name or by other things. The entries that you get back are sequence, which is a fancy name of saying that they're essentially arrays. So what does an entry look like? Well, every entry kind of depends on an entry of what, but they all kind of derive from the same basic entry type. So it's like object-oriented. You got the basic type with the certain fields that everybody has, and then additional fields or properties are available based on what the entry belongs to. So the basic fields are the name, a string, which might mean different things in different contexts, an entry type, which is just a string that tells you what type of entry you have, a start time, every entry has a start time, and a duration. Every entry has a duration, but the duration might be 0. So for example, if we are talking about the loading of the HTML, turns out that the loading of the HTML of the page is a really complex process with lots and lots and lots of steps. Again, I won't go into the details of all these steps. If you come to the workshop, I probably will. But enough to say that there's an entry for every one of these steps in the performance entry for the loading of the HTML. So there's an entry that describes the loading of the HTML, and in addition to those 4 properties, you will have all these additional properties with timestamp values, like performance. This kind of similar to the performance now value that we saw before. So how do I get at this particular entry? I do performance getEntryByType, of the type being navigation. Alternatively, I could have done getEntries, gotten all of them, and then filtered to find the one with the type equals navigation. Funny thing is that this would actually return an array, because getEntries always returns an array, but this array would have just a single element. Because iframes have their own context, so you don't get the HTML of the iframes in the context of their parent frame Each one of them would have their own buffer and their own entries. So what additional fields do I have in there? So first of all, I have the entry type, which is navigation. The name would be the URL. Start time, obviously, would be 0. And the duration will be the total time from when the navigation started until after the onload event is handled by your session. But there are other fields as well, like type, which tells me the type of navigation, how I got to the page, whether it's because regular navigation or I did a reload or something. There are additional data like transfer size and body size and so forth, so I can actually know the size of the HTML that I downloaded. I can even check out what the protocol was during the last hop to the browser, so I can verify that the protocol is what I expect it to be. So we looked at the entry that described the HTML, but obviously your web page is going to download a lot of additional resources, images, scripts, whatnot, and to them I can also gain access through the resource timing portion of the Web Performance API. Only successful downloads are included. There's no indication of caching. Again, you have touched on that because that would enable having cookie crumbs or checking which sites you've been at. And like I said, iframes have their own timings. But if you've got Chrome extensions, they're running within the context of the same tab, so those may be recorded. In order to get detailed values, not just the duration, you also have to enable cross domains, so you have to make sure that your response header has timing allow origin so that you can actually get to these values. Again, otherwise it'll just be zeros and you'll just get the duration, sorry. The graph for a resource is very similar to the graph for navigation, except that it's much, much simpler. That's why the browser kind of distinguishes between the HTML and all the other resources, because for all the other resources, you simply don't have as many fields. So how does that look? Again, you would do a get entries by type, type being resource. You've got the start time. This time the start time is actually meaningful. The initiator type tells you what caused that resource to start downloading. So for example, it might be a script tag, or it might be an image tag, or it might be the CSS because it's let's say it's a font. Or maybe it's an XML HTTP request, an AJAX request, so that's what you'll get there. And it might be even beacon. Interestingly, if it's fetch, as opposed to an XML HTTP request, the initiator type will be an empty string, which I find to be amusing. It'll also be an empty string for workers. So I'll actually skip that because I think we're low on time. But there are a couple of gotchas to worry about when using this API. You will have access to the slides, so you'll be able to look at that later. Yoav mentioned this. There's a paint timing API. So you do get entries by type paint. And currently, you get 2 entries and 2 entries only. One of them having the name first paint, and the other one having the name first contentful paint. First paint is basically just tells you when some pixel on the screen changed, whereas first contentful paint tells you when a pixel that's part of text, image, or non-white canvas or SVG has changed. So for example, if you've got a background color red, that would count as first paint, but not as first contentful paint. On the other hand, if you've got, let's say, the word hello, that would count as first contentful paint. So when you're looking at tools like Lighthouse and whatnot, they're actually using this API to get at this information. So the API The entries that we've seen so far are entries that the browser creates for you. It might be, you initiated the resource download, but you didn't need to create the entry. Because you had a resource download, the browser created an entry. Well, you can also create your own entries, and it can be very, very useful, and I'll show you why. So the basic type of entry is called a mark. You do performance.mark, you give it a name, it creates an entry. The entry has a name which matches that marker. And then you might put a marker at the beginning of an operation, and let's say another marker at the end of the operation. And if you look at the markers, you will see that they have the correct start time, which would be equivalent to doing performance now at the exact point when you did the performance mark. They have the name which matches the name. The duration would be 0. But you can then do a measure, and the measure you actually specify 3 strings. So the first would be the name of the measure, and then you might put the name of the start mark and the name of the end mark, and it would create a measure entry between these 2 marks. So the measure entry would have both a start time, which would match the start mark, and would have a duration, which would be the difference between the 2 markers. Why is that useful? I'll show you in a second. So what can you use the markers and measures for? So you can think about it as an ability to create logical entries as compared to the physical ones, let's say, that are created by the browser itself. You have a logical operation that might contain some asynchronous stuff, like let's say a user clicks a button, you do an AJAX request, you get back the data, you process the data, and then you display the data. So you might put a marker when the user clicked, and you might put the marker when you finish displaying the data, and you can measure that entire operation. And what's really cool about it is that it can integrate both with dev tools and with third-party analysis tools like web page test. And I'll show it very, very quickly because we don't have a lot of time. For example, if this is web page test, and hopefully you're all familiar with it, everybody knows what webpagetest.org is? So webpagetest.org is a very useful tool for measuring performance. It's free, it's open source. You just go into it, basically looks like this. You specify your URL, you specify some location in the world, you specify which browser you want to measure for, and you can also set various things like how many times to run it, whether or not you want to simulate some sort of network, and so forth. And at the end, you will get a report that looks something like this. This is a site that's built on Wix for the model Carly Kloss. And you get a waterfall that's very, very similar to what you might see in the Chrome DevTools Network tab. So every one of these represents a resource that was downloaded. So I can click to look at the various resources. So for every resource, I see like when it started and the duration relative to the other resources that were downloaded in the context of the same session. But so what's really nice is that in addition to the standard timing information that web pages is able to get, it also displays the marks that I placed in the code. So these numbers here are various markers. So forget the word beat, that's just an internal name for us. On the top you have our init happened at 1 second in this case, and we ran our bootstrap at 1.2 seconds, and we finished loading our packages at 4.4 seconds, and we did some rendering at around 6 seconds, and so on and so forth. So this gives you really detailed insight into the internal timings of your own session. So webpagetest.org shows you markers, but the DevTools is actually able to show you measures. So here's this site, here's this Carly Kloss site. If I click it, I'll go do inspect, I'll go to the performance tab, and then I'll record a load of the session. This is a very busy tab containing a lot of information, but it turns out that, so here I've got the network information, and here I got the CPU information, the JavaScript running information, but here in the middle I've got this thing called timing information. I'll zoom it a little bit, which actually shows me something very similar to those sections that you saw before in the Chrome, in the webpagetest.org. So if I create measures, the Chrome DevTools actually shows me the measures here built into the Performance tab. Now this is very useful because it makes it possible for me to understand that a certain logical operation started here, finished here. This is the JavaScript that ran during that operation. I can check which files downloaded during that operation. So it really gives me a really interesting insight into what's going on logically inside of my application. It's a really powerful combination of being able to use the DevTools together with this API. So I already mentioned this interface on the performance object, mark to create a marker, clear marks to remove markers, measures to create measures. Names, by the way, don't need to be unique. It'll just create additional entries with the same names if that's what you want. Even though it says start mark and end mark, it doesn't have to be mark names. It can also be names of the navigation object. So you can, for example, measure the time from when the first byte was received until when you, let's say, ran some operation. So you can actually use these names, and you can also remove measures using clear measures. And if you want to get the data for a specific mark or marks that have that particular name, you would use get entries by name and give the name of the mark or measure. This is not exactly part of the Web Performance API. It's a kind of a related API. It's not on the performance object, but it's actually fairly useful, so I want to mention it. Turns out that you have on the window navigator object, you have a connection object which can provide you with some interesting and useful information about the quality of the network connection as measured by the browser. It's called the Network Information API. Some interesting fields. So you've got the effective type, which is kind of like what the browser currently estimates the quality of your network to be. And valid values can be 4G, 3G, 2G, and slow 2G. So for example, you could decide that because your network is 2G and not 4G, you might download a lower res image, or maybe use an image where otherwise you might use a video or stuff like that. So one motivation for using this API would be to literally change the behavior of your application. Another motivation might be to include this in your reports, and then you can actually see what type of network your users actually have and then adjust your site accordingly. Because if it turns out that your users, all of them have really good networks, then you might use higher, more heavier features. But if not, if they have lower end networks, then you may want to throttle yourself. Some additional information. You've got the RTT is the round trip time. It's the time that it took from data to get from the browser to the server and back again. Also an indication of performance. And there are other stuff like here, like save data, which tells you whether you're in data saving mode. I won't even go there. But it's really useful. That I'll skip. Again, there's a way to basically be notified when new entries are created. You'll get to play with that if you come to my workshop. So to sum it all up, if you can't measure it, you can't improve it, said a guy called Peter Drucker, who I didn't know about until I found this quote, but it turns out he was a really big deal in the management circles, how to run companies and so forth. But I also find it really, really useful thinking about this way when I'm thinking about web performance. Because I can tell you from my experience, performance is never stationary. You're either improving or you're regressing. It's never fixed. Because you're constant, because in a theoretical ideal world, you would say, well, my application is good enough, I don't need to ever change it, my web page is good enough, my website, but then they probably don't need you, and then they would let you go. So you're there, you're busy, you're writing new stuff, you generally are making your site slower because of the stuff that you're adding into it. So with the Web Performance API, you will be able to measure both in development, in testing, and in production. You'll be able to check every aspect of the Rail model on all the browsers using a single common timeline, and you'll be able to know for sure whether you're making improvements or whether you're actually doing harm. So I wanted to thank you all for attending this meetup. I hope you enjoyed yourself, and thank you very much.